Alright, so we're going to try and make this quick for today, and I'm posting this a little bit late. I was hoping to have it done in the afternoon after school was over, and it's like a little after 5 o'clock. Got Meet the Team night, so here on campus. Just a quick review, things we talked about the past couple of days. The sum of the three angles, okay? Angles sum in a triangle. Don't need to put that up there. Equal 180 degrees. We talked about that after a couple of rotations. They want us to think about that possibility and look to how is that going to help me figure out how to solve this. Well, they don't give us some info. I'm going to give you some helpful info that will help us with this. Take your initial triangle. We know that this is 180 degrees. If I take and rotate it about the midpoint of one of its sides, I end up with another triangle that looks like this. So all in total, how much would the sum of this four-sided figure end up being? Well, gee, if this is 180, this is 180, together we get 360 degrees. So it says prove the angle sum of a quadrilateral is 360. We're going to write basically an if-then statement that proves that. We're going to say, if we rotate a triangle about the midpoint of a side, okay, then the sum of the angles of the quadrilateral and I'm having a brain fade because it is in the afternoon. Not quadra, lateral, the sum of the angles of the quadrilateral is equal to 360 degrees. So this is an if-then statement. If-then. There is kind of your proof. We can do if-thens. And the reason we do that is because now when they give us this figure right here, we should be able to look at this and say, well, gee, it's a four-sided figure. Yeah, true, this looks like a rectangle. I don't know that it is. All I can say is it's a parallelogram. This figure, I can't say what it is, except it has four sides, except it's a quadrilateral. So question 2, find the value of x, and oh my gosh, OMG, I just realized I need to move the camera here. Sorry about that. So now we're going to take the new figure, and we're going to find out the value of x. All right, this is a little bit different, so you have to pay attention to my directions, not the directions in the book. Find the value of x, so that's the first thing. Well, all these angles add up to 360, so think about that. The disconnect in geometry is students don't, it's practicing writing what your words are saying, what you say in words and writing things down. All angles add up to 360. Well, gee, everything equals 360. But what is everything? What do you mean everything adds up to 360? Well, it's quite simple. Angle A is 4x plus 23. We're going to go plus angle B, which is 7x minus 3, plus angle G, which is 6x minus 5, plus angle C, which is 16x plus 15. Right? Here's my four angles. All four angles are adding up to equaling 360. That's exactly what I said. I wrote out exactly what I said. All right, so try and make that connection. Now, how do I simplify this? And some of you are like, oh, but Mr. Wilson, it's a lot of work. No, it's really not that much work. And if you think this is a lot of work, then good luck in a higher level math class, because those classes are a lot more work than what we're doing here. 4x, 7x, 6x, and 16x. That's 33x. Go ahead and count it up. Right? Use a calculator. 23, 7, minus 5. 23 minus 3 minus 5, and 15 gives you plus 30, right? And no, I didn't do that in my head real quick, okay? This is the 6th time today I'm doing this, so after 6 times you think I ought to remember what the answers are. Use a calculator and add it if you need to. So I'm going to subtract 30, and I think I can do away with the green now and end up with 2. So I'm going to get 33x is equal to 330. Divide by 33, and x is equal to 10. All right, so I found the value of x. Now, and again, I'm adding this. You better put this in your work because I'm going to look for it. Find the value of each angle. How do I find the value of each angle? Well, here's A, here's B, here's C. I'm not sure, or G. I'm not sure if you can see C, but that's okay. You're going to get the idea. If A is expressed as 4x plus 23, then 4 times x plus 23 is going to be equal to the measure of that angle, right? So A, well, what is x? We just solved for it. X is 10. Why am I putting in there? I should put 10. So now I'm just going to simplify. 4 times 10 is 40, plus 23 gives me 63. And I'm going to go ahead and label this 63 degrees. Now, follow suit with all of the other ones. I'm not going to sit there and do them for you, all right? But you follow suit with all the other ones, and when you add them up, they should be equal to 360. Okay? So I would pause and do that with the rest of those, because I'm going to move on and share with you the rest of the material. Now, 3 through 7. What are we going to look at over here? Well, if we look at 3 through 7, we should look at these problems, 3, 4, 5, and 6, and recognize that they're in the form of y equals mx plus b. Why? Why is that important? Well, that's important because m is the slope and b is the y-intercept. Knowing that information, I'm going to be able to answer all 4 of these and answer question number 7. Look at number 3. I don't care that the slope is 3/4. I care that it's positive or negative. Okay, it's a positive slope, which means it has to be one of these 2 lines, because those are the only 2 lines that have a positive slope on my graph. The other thing I take into consideration is the y-intercept. A positive slope and 2 as a y-intercept. This y-intercept is 2, this y-intercept is 4. I just eliminated r as an answer because r has a y-intercept of 4 and a positive slope. So this is S. Number 4, negative slope. Got to be P or Q. Crosses the y-intercept at 2. Has to be Q. Do the other 2 and pause, and I'm going to give you a second to do so and come back and I'll answer question number 7. So pause. Now, try and answer question number 7. What do you think about question number 7? What do you think your answer is? Look at this shape. I'm hearing everything from diamond to square to just other stuff. Rhombus. Now, the only thing I know about this figure is that I have 2 sets of parallel lines. Whenever I have 2 sets of parallel lines and opposite sides are parallel, the only thing I can say is parallelogram. I cannot call this a rhombus because a rhombus, it would either have to tell me it's a rhombus or it would have to somehow tell me that all of these sides are the same. In order for it to be a square, I would have to know 90-degree angles. All right? And then the last thing in this section that we need to look at is we need to look at the questions here in the set. And that is questions 8 through 16. I'm going to help you with question 8, which is the pair of scissors there. All right, I'm going to move this back so it's not too close. When you look at a pair of scissors, okay, and it's asking you, gee, do I see vertical angles? Do I see parallel lines with the transversal? Or do I see an exterior angle of a triangle? How am I going to answer this? I'm going to see the pair of scissors, and this is going to be horrible here, okay? But I'm going to put the scissors up here, and we're going to do this. Here's my pair of scissors. Do you see parallel lines? I don't. But if I did, here's how I would write it down. Parallel lines with a transversal. If I can write. Again, I can't speak and I can't write today. That's how I would write it. Okay? Do I see vertical angles? Yes, I actually see vertical angles. So here's how I'm going to write that. Vertical angles. And then lastly, do you see an exterior angle of a triangle? I don't see any triangles here because triangles, it would have to be closed off. It's not closed off. But if I did, here's how I'm going to do this. Exterior angles of a triangle. Oops, and that should be of a triangle. That's how I'm going to answer that. Right? So the only thing I see in this one here is vertical angles. That's the only thing I see there. Now, what about 9? Because I helped everybody else out with 9. All right, might as well help you guys out. Here's my picket fence. What do you see? Do you see parallel lines with the transversal? I see parallel lines, and I see a bunch of transversals. So yes, I'm going to write parallel with transversal. Do I see vertical angles? Anytime you see two intersecting lines, here's an intersecting line, here's a line, and here's a line. Anytime you see that, you'll see vertical angles. There are lots of vertical angles everywhere. So yes, vertical angles. And then the last thing it wants to know is there an exterior angle of a triangle? Well, you should see a couple of triangles in this figure. I see a triangle here, and I see one here. Notice my diagram's not as great as the one on the paper. To be an exterior angle, it's going to be here. Remember, you just extend a line and that creates an exterior angle of a triangle. So right there, there's a couple. So yes, this one is going to be all three. Exterior angle of a triangle. All right? Now, go on a limb there. Number 10, do you see any parallel lines? No. So you're not going to write that one down. All right? Answer the rest of those. Just to 16.